All right. So mathematical induction. In math, we like proof that something is true. Maybe you don't, right?
No.
But we like to verify that things are true. Okay, what's the point of doing something if we can't prove that it's true, right? So in geometry, you wrote a bunch of proofs, and some of you enjoyed them, some of you hated them. It does not matter what your feelings were at the time. Okay, we are going to study mathematical induction in this section, which is a type of proof, much different than your geometry proofs, but still a mathematical proof of something. Okay, we use mathematical induction as a strategy to prove something that's based on a sequence. Okay, so we can either prove a sequence. It might be a sequence that sums up to something. Okay, but it's thrown into this chapter because we're using it with a sequence. All right. So, like I said, it's going to look much different in your proofs in geometry. We're not going to make 2 columns and list out 1, 2, 3, 4 and give theorems for why we're saying what we're saying. Okay, this is going to be more kind of like a paragraph core. Okay. So, this is the principle of mathematical induction.
What?
Okay. First of all, you are going to be given a statement, okay, that deals with positive integers n, all right, much like a sequence or a series does, right? So you're going to be giving a statement, P sub n. Our strategy is going to be to first of all prove that P sub 1 is true. Okay, so more than likely you are going to get a sum of a sequence and it's going to equal some shortcut formula. Okay, so we're first going to prove that it works when we plug in just 1, so it's just going to work for the first term. Then if we assume that it works for k, we're going to show that if we know pk is true, then it's then p sub k plus 1 is true. Okay. If we can do all of that, then we know p sub n is true. Okay. All I said was a bunch of gibberish to you right now. Write it down because you'll need this today and tomorrow. But we're going to talk about why the heck this makes sense. Okay. So what does this gibberish mean? Okay. I'm going to give you an analogy, all right, that you should be familiar with. We're going to compare it to that. So we're going to talk about the analogy and then bring it back to how does that pertain to mathematical induction. Okay, keep in mind that we're working with like the sum of a sequence or terms of a sequence, okay? So dominoes. How many of you have lined up dominoes and hit them down to watch them all fall? Right? Kind of fun. but a lot of work for only a couple seconds of satisfaction, right? All right, so what we're doing is we're setting up our dominoes, okay? First of all, we need to set up our first domino, right? And I'm not going to read through all of this. This is more for if people are reading my notes online, okay? So we have to set up our first domino, okay? And we know that when we knock over a domino, the next one goes on, right? Well, what we're doing is we're setting up our first domino, and then we have all of these random dominoes, okay? If I can say that no matter what, any domino that I pick, that's kind of like our K, all right? Any K domino that I pick, if I can tell you that if I pick any domino and it's going to make the next one fall, then if I hit that first one, they all should fall down because 1 makes 2 true, makes 3 true, makes 4 true. Okay, 1 hits 2, hits 3, hits 4, all the way down the line. Okay, so if we can take this this sequence that we're working with, and we can show that this shortcut summation is true for 1, okay, then we can pick any random domino, okay, that's our K. If I plug in K instead of N, that's just saying, okay, choose a random domino and make sure that it's going to hit the one before it. All right, so we're going to plug K in to our formula that we have. And if that is true, or if that makes the next one true, and we can show that with algebra, okay, then when we hit that first domino, they're all going to fall. Or in the terms of what we're proving, if 1 is true, then we know the rest is going to be true because of that domino effect. Okay? How does that sound now that I've explained that a little bit? What? A little better? Okay. So let's go back to this. Okay? We're basically going to have 2 steps in this process. Step number 1, show that it's true for 1. Okay, we have to set up our first domino. Okay, as the showing that it's true for 1, first step. Okay, going to be the easy step. All right, then we need to show that by plugging in K. Okay, so piece of K. That just really means change your N's to K's, okay? Show that piece of K is going to make the next one true, okay? So piece of K to K plus 1. Can we show that
For the following groups, please go to the gym for pictures. National Honor Society, both current and new inductees, Titan Tech, Leo Club, and debate. Once again, National Honor Society, both current and new inductees, Titan Tech, Leo Club, and debate. To the gym for pictures.
Okay. So we'll set up our first domino with piece of 1. And then we'll choose a random domino and say, okay, as long as K makes K plus 1 true, then we've proved that whatever we're working with is true. It's going to be true for anything. All right. Now, today what we are going to focus on is just what piece of K looks like versus piece of K plus 1. Okay. Tomorrow we'll actually go through the entire proof process, but for right now we're just going to look at, okay, if you have piece of K, what would piece of K plus 1 look like? Because that's going to be your goal for tomorrow. When we actually prove this, we need to be able to get from K to K plus 1, and so we need to have an end goal in sight. Okay? So, questions so far? Okay. So here is p sub k. Tomorrow, what your problems are going to look like is you're going to have the sum of a sequence equals maybe something that looks like this. It's going to be kind of like a shortcut. All right? So we need to be able to tell what k looks like and what p sub k plus 1 looks like. That way we know where we need to get to with our algebra to prove that this is all true. All right? So p sub k plus 1, what would that look like? We have 6 over what? K becomes k plus 1. K plus 3 becomes k plus 1 plus 3, right? So k plus 4. Now tomorrow there'll be something on the other side over here, and we'll have to do algebra to get from here to here. But that's what we're going to work on tomorrow. But we need to know where we need to get to. Okay? Okay. Everyone okay here? Okay. This is something that we might see like on the other side. Okay, so we're going to have something like this, and it's going to be equal to something that we saw on the first page. Okay? So let's look at what would k plus 1 look like. All right. All right. What would this look like? We're still going to have 2 plus 5 plus 8. Okay. Then what happens when we plug in k plus 1 here? It becomes k. So this is just 3k minus 1, correct? And what happens when we plug in k plus 1 here? Okay, this is k plus 1 minus 1, right? Please be careful there. What does that simplify down to? K plus 2. Yes. Three times k plus 1. Better? Okay. All right, now what I want you to notice is what does this from here to here look like? What does it look like? Look at the very first line. Anybody?
Wait, what was the question again?
Does that look familiar? 2 plus 5 plus 8 plus all the way to 3k minus 1. Okay, that's what we started with, right? That was the sum of the first k term. Okay, so, okay, this is representing the sum of the first k terms. Here's the sum of the first k plus 1 terms. There's one extra term in there. Okay, do you see that? Okay, that will be important for tomorrow. All right. How about this guy? I want p sub k plus 1. What would that look like? K plus 1 squared k plus 1 squared over 4. Okay, this is literally all you're doing in tonight's assignment. Okay, please make sure, okay, now up here a lot of people got tricked and wanted to only write 3k. Please make sure if k is being multiplied to something, you need to put k plus 1 in parentheses so it gets distributed. Okay, notice how k was being squared, so k plus 1, I put that in parentheses so the square could go to the entire quantity. Okay, notation is going to be important. Alright? You should be able to get this done before you leave.
Okay, let's go. One more. Okay.